So as you're looking today, class, we're learning how to write the converse, inverse, and contrapositive of a conditional statement. Your essential question is, how do I write the converse, the inverse, and the contrapositive statements? Learning intention. I am learning to write converse, inverse, and contrapositive of a conditional statement. So what is the distance between the 2 points? Here's your 2 points. We're going to use the distance formula. So pause the video and see if you can set it up now. Well, I hope you tried to set the equation up on your own. So does it matter which point I start with? No. So I'm going to call this x sub 2, y sub 2, x sub 1, y sub 1. So I've got negative 10 minus 8, quantity squared, plus negative 4 minus 8, quantity squared. The nice thing about having a really nice calculator is the fact you can put it in all at once. So as I'm looking at this, I need to find my square root button. It's down here in yellow. That means that I've got to hit the yellow button and then the x squared button, and that gives me the square root. Now if you notice, I've got parentheses. I've also got one here, but I need to put a second parenthesis there before I get started. So use your negative symbol. Do not use the minus or you'll get a syntax error. Negative 10 minus 8, close it and square it, plus parentheses, negative 4 minus 8, close it and square it. Now you need one more parenthesis to hold it all together. Hit enter and you get 21.63. I'm rounding to the nearest hundredth. So it's 21.633. So this is approximately 21.63. And that would be units because we don't know what our distance is in. Okay, so that's the first one. The second one says the endpoints of a diameter of a circle are negative 4, 14, and 4, negative 8. Find the center of the circle. And what is the length of that radius? Round to the nearest hundredth. Okay, so this is two different problems, but one has to follow the other. If I've got endpoints and I want to find the center of the circle, and if I want to find the midpoint, that's the formula. X sub 1 plus x sub 2 divided by 2. Same thing with your y. Y sub 1 plus y sub 2 divided by 2. We are finding the average of those two numbers. That's why it works. Does it matter which is x1 and x2? No. I just have to remember this is x, this is y, likewise x and y here. So for my midpoint, my center, I will take negative 4 plus 4 divided by 2, and I'll take 14 plus negative 8, and I'll divide it by 2 again. Any questions? Okay, let's do the math. Negative 4 plus 4 is 0, divided by 2 is 0. 14 plus negative 8 is positive 6. Positive 6 divided by 2 is 3. So our center is 0, 3. So it's on the origin. And not on the origin, but it's on the y-axis. 3 units above the origin. Okay, so now, what about the length of the radius? Does it matter which point we use? No, because the radius divides that diameter in half. So we can use either set of points and our distance formula a second time, and we will find that length. So I am going to choose the first one just because it's first. So for my distance, the square root of parenthesis 0 minus -4. Close it, square it, plus 3 minus 14. Close it, square it. Now remember, with our calculator, we've got to have that other set of parentheses also. Now, as you're looking at this, I'm trying to minus a negative number. I know that's not what you're supposed to do. I'm supposed to plus it, but the calculator will do that for me, or I can automatically do it in my head and put it in that way. So let's get started. Second, x squared gives me my parentheses. First parenthesis, 0 minus -4. Close it, square it. Plus, parenthesis, 3 minus 14. Close it, square it. Add that last parenthesis so it's all held together and hit enter. And it tells me 11.704. So if I go to the nearest hundredth, that is approximately 11.70. Okay, if you have trouble with the math or understanding how to apply those two formulas, please come have a conversation with me. Now, when we talk about conditional statements are in the form of if P then Q, where P is your hypothesis and Q is the conclusion. The converse statements are formed by switching the hypothesis and the conclusion. Okay, if we're writing it in symbolic form, if Q, then P, we're just switching our hypotheses and our conclusions. This is what it would look like. P goes to Q, or Q goes to P. Okay, so now we're going to write the converse and then decide if it's true or not. If it snows 6 inches, then school will be canceled. So the hypothesis is it snows 6 inches. The conclusion is school will be canceled. So let's rewrite it. If school will be canceled, then it will have snowed 6 inches. True or false? Is the only time school is canceled when it snows. What if our electricity goes out and we don't have electricity? Will we have school? My room would be really dark, so I hope not. So I would say that this one is false. we could have the electricity could go out. And then cancel school. Oh, they could cancel school for a holiday. We usually know about those ahead of time, but that's another reason school would be canceled. So just because of snow does not mean it will be canceled. It's not the only reason it could be canceled. Okay, if a quadrilateral has 4 congruent angles, then it is a rectangle. So we're going to switch it around. The hypothesis is the quadrilateral has 4 congruent angles. The conclusion is it is a rectangle. So we're going to switch them around. If it is a rectangle, then it is a quadrilateral with 4 congruent angles. Is that a true statement? What is a rectangle? It's a quadrilateral because it's got 4 sides. All of the angles are 90-degree angles, so this would be a true statement. Even if you say, what about a square? Well, a square is actually a quadrilateral. So that's how you do the converse. So the inverse is formed by negating the hypotheses and conclusion of a conditional statement. If not P, then not Q. So we're changing them both to not. State whether the inverse is true. If not, give a counterexample. So our hypothesis is it is a square. Our conclusion is it is a rectangle. Okay, so let's negate both. That means we're going to change them into not. If it is not a square, then it is not a rectangle. True or false? Are squares the only type of rectangle we have? No. And I can do the counter example. Here is a rectangle, but not a square. So any rectangle that's not a square will work, because it says that if it's not a square, then it can't be a rectangle. And we know that's not true. Okay. Okay, pause the video. Can you do the next one on your own? Pause the video now and see if you can underline the hypotheses and the conclusion. So, hypotheses, two lines intersect. Conclusion, they intersect at a point. Remember, we're just negating both of these. If two lines do not intersect, because that's the opposite of intersecting. Then they do not intersect at a point. Okay, so they're not going to intersect. Will they ever touch? No, they will not. So that is a true statement. They'll never ever touch. So this will be true. Okay, that brings us to the contrapositive. The contrapositive is kind of like when we did the Converse where we switched out Q and P, but this time we switch them out and we also negate them. So we're going to switch them out and negate. Start out by underlining the hypotheses and the conclusion. So we have to change them into not. And we start with the second part. If there is not exactly one plane that contains them, then you do not have three non-collinear points. What do you think? True or false? Can we have three non-collinear points that would not be found in a plane? If there is not exactly one plane that contains them, so we're just looking out in space. Can you have three non-collinear points? You will not have three non-collinear points. Well, it's kind of like the definition of a plane. It contains any 3 points. Non-collinear points are contained in one plane. So if you don't have the plane, then you can't have the non-collinear points either, or they would be in the plane. So this would be a true statement. Okay, last one. Pause the video. Underline the hypotheses and conclusion at least, because I know you can do that. Try to rewrite it. Hypotheses. If you have 2 points, conclusion, there's exactly one line that contains them. Negate it, change it around. If there is not, one line that contains them, then you do not have 2 points. Okay, with or without a line, can you have 2 points? Yeah. So that one would be false. And all I have to do is, here's point A, here's point B. I could draw the line, but I don't have to have it. And I can still have 2 points. So, I know I'm successful when I can write the converse, inverse, and contrapositive of a conditional statement. Hopefully this explains how to rewrite them.